Okay, so today we're going to be looking at algebraic fractions, and the first part of this area is going to be on cancelling. It's really important because lots of algebraic fractions are in fact very simple problems to solve once we simplify both the numerator and the denominator. Now I've got a question here, and it's really x divided by x. Now this works exactly the same way as it does with numerical values. So 3 divided by 3 is just 1, 4 divided by 4 is also 1, and so on. So any value that is divided by itself is obviously going to be given the value 1. So x divided by x is also just 1. So that's something that still, strangely enough, people do mistake. Now, when we get into the rest of this, I just want you to notice that there's a common thread that we can use to illustrate common factors between each the numerator and the denominator. So if we look at this one, 2x, I'll do this all off first. If I look at this one, 2x divided by x, what this is actually saying is 2 times x all divided by x. Or it can also be expressed as 2 over 1 times x over x. And we know that x divided by x is just 1. When we cancel factors, we also tend to draw a line through them. So how many times does each one go into it? Well, 1 time. And that leaves us with 2 times 1, which is just 2. But we don't really need to do that. We just have to recognize that this is another way in which we are showing a common set of factors that when we separate it out just equals 1. And if that's the case, then we can get rid of it. So in this first instance here, we could have cancelled straight away. And that would be 2 times 1 over 1, which is just 2. Okay, so this equals 2. Just remember that as long as it gets even more complicated, we can do the same thing as many times as we want and eventually just stop doing it altogether. There's no pencil. Right, so let's look at the next one. So if we look at this one, we have x divided by 2x. Now again, this is implied multiplication between the x and the 2 and the x, and we can find a common factor. This is the same as 1 times x divided by 2 times x, okay? Both the x's are going to cancel because they're a common factor, leaving us with 1 times 1 over 2 times 1, which is just going to be equal to a half. And again, you don't need to always do this. You don't need to actually do all of the working for this. Once you get comfortable with it, you can just go straight to where you need to go. Now, when we have the same thing, it's really just the same problem with a different pronumeral. So if we look at this one, we have a divided by a squared. And what is a squared? Well, that's a divided by a times a. Okay? And that is just the same as a multiplied by 1 multiplied by a divided by a times a. And we can separate this out, which is to be 1 over a multiplied by a over a. But the idea is that both of these cancels and make 1, right? We can cancel both of these factors here, go into it 1 time, and we're left with 1 over a. And we can really see this at the start. When we end up with the same factor, both on the top and the bottom, or the numerator and denominator, we can immediately cancel. You just have to remember that if we're dividing these both by each other, we're still going to end up with that 1. Alright, now let's look at something a little bit more difficult. So with this one here, we have a little bit more of a complex set of different factors. But the same principles apply. This is the same as 3 over 9 multiplied by x squared over x multiplied by 1 over y. This is all the same. And the reason why you can check this is the same rules apply with just numerical fractions. We have multiplication. We just multiply all the numerators together and all the denominators together. So we can separate this out. We don't have to, but it's good kind of conceptually to see how we actually are cancelling these factors. So we have 3 and we have 9. What's a common factor between 3 and 9? Well, it's 3. So let's divide the top and the bottom by 3. Dividing the 9 by 3 gives us 3, and dividing the 3 by 3 gives us 1. So instantly we've changed this to a more simplified fraction where we have a third. Still going to be the same. 3 over 9 is the same as 1 over 3 because with equivalent fractions, we've divided both the numerator and the denominator by the same exact value. So nothing has changed, it just looks different. Okay, what is the common factor between x and x squared? Well, x is a common factor between x. Let's divide both the numerator and denominator by x. X divided by x is just 1. And x squared divided by x, well, we can just get rid of that exponent or that index and left with just x. Okay, so we're left with x over 1. And is there any factor between the numerator and the denominator between our 1 and our y? Well, no, there isn't. And that means that we don't have to worry about this. We can't simplify that anymore, and it's left to 1 over y. Now, multiplying this all together, 1 times x times 1, well, that's just x. And 3 times 1 times y, well, that's just 3y. Now, you can see in our simplified version here, where all of our cancelling has taken place, there are no more common factors. And if we can't find any more common factors, then we know we've simplified it fully. Okay, next one we have is 12ab divided by 4a squared b. Now, we don't need to do as many steps as we just did. We can immediately start cancelling. We can immediately find which factors we're going to divide by which factor. So let's start with the numerical values or the coefficients. What is a common factor between 4 and 12? Well, 4 is probably the highest common factor between them. So let's divide the bottom by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. Okay, what's a common factor between a and a squared? A is. Let's divide the top by a and we get 1, and the bottom by a and we just get a to the power of 1. Then we have b and b. So what's a common factor between b and b? What's b? Dividing both by b gives us 1. And so we're left with 3 times 1 times 1, which is just 3, divided by 1 times a times 1, which is just a. So we're left with 3 over a, and that's fully simplified. And if we wanted to look at this further, we could expand it. So that is exactly the same. And all I've done is I've broken up the a to the power of 2 into a times a, and we can see that we got this common factor dividing both through a, and we're left with just the denominator a. And when b is divided by b, well, this will just resolve into 1. And then obviously we will get the same value here, which is 3a. So it's the same thing. And you can just make sure, if you want to do it this way, if you want to do it quickly, it is something that you can do. Obviously, if you're not comfortable with doing that, just separate it all out until you are. All right, that's it for this video. Hope it was helpful. I will see you in the next one.